Okay. So this is fifth question, third part. Exercise 2.3. So they want you to give an example of Px, Gx, Qx, and Rx in such a way that degree of remainder is 0. So this should be simple, right? There is no other constraint. You just want the degree of remainder to be 0. And just now I taught you that if you want the remainder, the degree of remainder to be something, all you have to do is just think about what should be my degree of Gx. If this should be of degree 0, if your remainder if you want the remainder to be 0, what should be my condition?
There should be a factor.
Mhm.
Gx should be a factor of Px.
Yes, Gx should be a factor of Px. Does it have to be? Is that true?
No, sir, since it will be
Sir,
1,
if it's 0,
remainder will be 1.
Okay. See, don't forget, this is just the degree to be 0, not the remainder has to be 0. Remainder can be something else.
yes sir, yes sir.
Okay.
Then both should be of same. Gx and Px should have same degrees, sir.
See, why are you even thinking about Px right now? What did I tell you? If you want the degree of remainder to be 0, remainder is directly related to the divisor only.
Yes, sir.
Remainder is only related to the degree of remainder is directly related to the degree of divisor.
Yeah, divisor.
How is that? How is it related?
Sir, the degree of divisor will be one more than remainder, sir.
Not only one more than, it has to be more than. It can be any number more than. Yeah. So for keeping it simple, we will keep it one more than that. So here, if you want the degree of remainder to be 0, for a simple thing, you can keep the degree of Gx to be 1. You can keep more than 1 also, remember. 1, 2, 3, 4, 5, whatever you want, you can keep it. But to keep it simple, keep the degree of Gx to be 1. Okay. Why? Because degree of the divisor Gx is always greater than the degree of remainder Rx. So if degree of Rx is 0, the degree of Gx has to be greater than 0. So greater than 0 means we can pick anything greater than 0, should be 1. So we know that degree of G of x can be greater than 1. So let's pick it, let it be 1. So what will be my Gx? We can take any degree 1 polynomial, your wish. Someone throw me something.
X plus 2, sir.
Okay, x plus 2, very good. It is a degree 1 polynomial. Now, what should I pick my Px then? Is there any condition I have to do? Nothing, no condition. I can pick any degree. Because whatever degree I do, I know that degree of remainder will be less than 1, and less than 1 will always be 0. So whatever Px I choose, it doesn't matter. Remainder will always be 0. The degree of the remainder will be 0, not the remainder itself, but the degree of the remainder will be 0. So let me pick something simple. X square 5x plus 3. Okay, then do the division. So it will be x plus 2 dividing x square minus 5x plus 3. Do the division, guys. See if anyone can do it faster than me. I'll try to do it a little slowly.
Sir, I took another example, sir. I completed.
Yeah.
I got remainder as 25.
Okay, that's good.
Sir, so the remainder should be 1, no, sir.
Remainder doesn't have to be 1. Remainder can be anything. It should be constant polynomial. because every constant polynomial has a degree of 0. Read the question. What are they saying? They're only interested in degree of the remainder to be 0. So what does it mean? Remainder can be any
Okay, sir.
constant polynomial. Okay. And how will that happen? We have to pick some gx. Gx, the degree of gx should be greater than the degree of remainder. So I am going to pick gx degree to be 1. Degree of gx to be 1. So if you pick something with a degree 1, like x plus 2 we did here, then of course you are going to get a constant polynomial. There is no other choice. Remainder can be 0 also sometimes. If you pick some example which is exactly a factor of this, you may get a remainder 0, but try to avoid that, because if you get a remainder 0, then this will become a 0 polynomial. And 0 polynomial, the degree is not 0, remember. The degree of a 0 polynomial is what? Anybody know, remembers it? We studied this in 9th standard. What is the degree of a 0 polynomial? Means degree of 0. It is undefined. I had explained why it is undefined also. Okay, so try to avoid an example where remainder turns out to be 0. If you, by mistake, if you choose something, just make small change into that. Just change some constant or variable, coefficient, whatever. Okay, so like this, here I'm getting 17, right? So this is a constant polynomial. And what is the degree of this constant polynomial? It will always be 0. So degree of Rx is 0. So write it down. Your Px is x square minus 5x plus 3. Gx, we have carefully chosen to be x plus 2 because it has to be of degree 1. Only then my remainder will be less than 1. That is constant polynomial. Qx, we don't care, but still write it down because we have to write everything. What is my Px, Qx, Gx, and Rx? Everything we should write it down. So since we have shown the division over here, it will definitely follow the division algorithm, and we can see that whatever condition they had asked us, we have fulfilled that condition. Remainder is of degree 0. Okay, so is that okay, guys? Are you people clear with this? These 3 questions?
Yes, sir.
Yes.
So I'll send the notes and go through the PDF, and then if you have any questions, you can ask me in the next class. I will try to clarify if somebody has missed anything. Okay. So try this on your own. It's a very simple logic. The constraint between all those things are very simple. Only one rule you need to remember. Degree of the remainder is always less than the degree of divisor. And also, okay, let me write down some rules for you. Rules related to this. Okay. Important note. So you will degree of divisor gx is always greater than degree of remainder. First rule. You should also understand that degree of gx plus degree of quotient, that will be equal to the degree of, can anyone tell me? Degree of gx, when you add it with the degree of qx, what should it be equal to? It should be equal to the degree of what? See, quotient and divisor, when you multiply, yeah, when you multiply, then only you get your px, right? So when you multiply these two, what will happen? The degree will get added, right? So the degree of px actually here. So degree of px is actually nothing but the sum of degree of gx and qx. So if you just remember these two rules, you should be able to solve those three questions over there. Okay. Fine. So I think we have spent a lot of time on this today. So the fourth question I'll explain in the next class if anyone needs. Okay.